In this class, I will explain about an important concept called moment of a force and also a couple. So, you know that the external effect of a force on a body can be in two ways. One is the force can translate a body. Translation means when you apply a force on a body, this body may move in the direction of the force. That is called as translation. So either it can be in the horizontal direction, or it can be in vertical direction, or it can be in the inclined direction also. Suppose if the body is like this, if the force is applied like this, so the body may move in this direction. So that linear motion is called as translation. And the another effect of the force is rotation. So if a force is applied at some point on a body, with respect to some other point, the body may start rotating. So that is rotational effect. So it can be either clockwise rotation or anti-clockwise rotation. So that rotational effect is nothing but due to the moment of a force. Now to define the moment of a force, I will consider a body here. So on this body, a force F is applied at a distance d, perpendicular distance d, from a point A under consideration. Now the moment of this force F above this point A is defined as F into D. That means it is the product of the magnitude of the force multiplied by the perpendicular distance of line of action of the force from the point under consideration. So here in this case it is F into D. So this is called as the moment of the force, magnitude of the moment of the force, and in this case this force F tries to rotate the body in the clockwise direction. You can see here. So to understand the rotation effect, so you have to consider the arrow. So the force is acting like this in this direction. Arrow means the direction, and about this point the body tries to rotate like this. So that is the rotation I have shown here, clockwise rotation. And the moment which causes the rotation is denoted by MA. MA is nothing but moment at A. Here A is called as the moment center, the point about which the moment of force is considered, that is called as moment center. And the perpendicular distance from the moment center to the line of action of the force, it is called as the moment arm or lever arm. Here D is called as the moment arm or lever arm. Suppose if the force is acting like this, thus another force P, force P is acting like this, then what happens if you observe about the point A, this force tries to rotate the body in the anti-clockwise direction. Of course the value remains same, if it is P into D only, P into D. So here P into D is anti-clockwise in direction, F into D is clockwise in direction. So like this, there may be number of forces acting on a body. So we have to find the combined effect of all those forces, rotational effect of all those forces, by considering the moments of individual forces with respect to any point. And when you are considering the algebraic sum, the total effect, normally we take clockwise moments as positive, anti-clockwise moments as negative. Just like in the analysis of resultant problem, we take sigma fx when you are finding forces acting towards right positive, left negative, and sigma fy forces acting upwards positive, downward negative, like that. The convention for moment is clockwise positive, anti-clockwise moment is negative, like that. So that is called as the moment of a force. The second term is couple. So you know about the different types of forces, classification of forces. If you consider parallel forces, two equal or a pair of equal opposite parallel forces separated by a definite distance, of course, they constitute a couple. So like that means suppose I take two points here A and B on a rod. Let us say this is a rod of length D. So then what happens here, at end A, there is a force, upward force of P, At end there is a downward force of same magnitude P. So you can see that they are equal forces, both are equal to P, magnitudes are equal, they are parallel and opposite direction. You can see the arrow, opposite direction. So if you represent the two forces like this, then we say that it constitutes a couple. So what is the effect of couple? The effect of couple is also rotation of the object. So due to this, this rod starts rotating like this. Best example is pedaling of a bicycle. So pedaling of a bicycle, when you start pedaling, the wheel will start moving. So you will be moving on the cycle. So this is an example. Couple. We are applying equal force on both the sides, on both the pedals, but in opposite directions. So in this case, magnitude of couple, which I denoted as C, C stands for couple. Here also, magnitude of the couple is given by product of magnitude of the parallel, one of the parallel forces multiplied by the distance between the parallel forces. So P into D. Similar to your moment, couple is also magnitude of one of the forces multiplied by the different distance, that is D. So here only thing is either it can be clockwise or anti-clockwise. In the first case, in this case, so you can see the effect of this. You consider any point here. If you take a point C here, so the effect of this P is clockwise. The effect of this P is also clockwise. That means, so finally you are getting a clockwise couple of magnitude P into D. Suppose if the forces directions are reversed like this, at A it is downwards, at B it is upwards, then the effect of this will be anti-clockwise, because we consider any point C here, the effect of this P is anti-clockwise about C, the effect of this P is also anti-clockwise. So therefore it is subjected to an anti-clockwise couple, which we, by such convention, we take it as negative. So clockwise couples we take positive, anti-clockwise couples we take as negative, just like moments. So couple also causes rotation of the body. Only thing is, it's a special type of moment wherein two equal opposite parallel forces are acting on a body. Now, what are the characteristics of couple? So it's an important question. So now to understand the characteristics, what I do is, I will take a body here. On this body, I will take two forces are acting on this body at points A and B, equal opposite parallel forces. So P and P separated by a distance D, same thing like this. Then I will take a point C here, somewhere on the line AB at a distance x1 from A and x2 from B. Now what I do is, I will try to write the expression for the moments at the 3 points A, B and C. Moment at A, it is denoted by MA. If you see here, this force P, this force is not giving any moment about A, because moment is given by force into lever arm, that is perpendicular distance. Since this force passes through A, it doesn't have any distance from A, therefore the moment due to this P is 0. What about moment due to this P? So it is at a distance D now. So moment of this P about the point A will be clockwise. You can see here. So always you have to calculate the moment with respect to a point or an axis. So that means moment of this P about this point A is clockwise, which is P into D. So moment is defined as force multiplied by the perpendicular distance. It is P into D clockwise. I have written here. Similarly, moment of the force is about point B. If I want to calculate, this point P will not have any moment about this point B, because that point P passes through B, your perpendicular distance is 0, whereas this force P gives a clockwise moment about B, and the value of that moment will be, so P into D once again clockwise. You can see here. Then I will take the moment about the point C now. Moment about the point C will be due to this also we have to consider, because these two forces are not passing through C. You will have some distance. So here, if you want the moment of this P about the point C, it will be clockwise. See here, it will be clockwise. Distance is x1. So P into x1 clockwise, positive. I will take clockwise as positive. Then come to this P. Momentum of this P about this point C will be P into x2. P into x2. That is also clockwise. So both these two are clockwise, and if you take common P, x1 plus x2 is nothing but D, that is P into D itself. So that means what you can say here is all the three moments are equal. MA, MB, MC. All the three are equal and they are constant. Okay? It is equal and constant. Now, what is the meaning of this is magnitude of couple remains same in the plane. So you have proved that the values of the moments at A, B and C, they are same. The net effect of these two forces on this body is it tries to rotate the body like this, C, which is equal to P into D. C is the couple there. So moment and couple, of course, you can say it is same here. So in this case, magnitude of the couple remains same in the plane wherever you consider. Now if you list the characteristics of couple, I can list like this. Couple is nothing but it's a pair of parallel, equal and opposite forces separated by a specific distance, and the effect of couple is rotational effect remains same in the plane. So it has got only rotational effect which is constant, which I have proved here. Translated effect is not there. So translated effect of a couple will be 0. Then effect remains same if it is shifted to any other point in the plane. So what the meaning of this is, suppose you have a couple acting here, clockwise couple acting here, some P to D. Suppose if you shift this P to D same clockwise somewhere here at this point, here also P to D, then the effect of this P into D, wherever it is applied, it may be applied here also, C, so P into D, but the thing is its magnitude as well as direction should be same. So I have taken P into D moment or the couple, P into D couple at three different points in the clockwise sense. So the effect of this and this are same. That is the meaning of this fourth point. So these are the characteristics of a couple. Now as an example, I have taken a simple example here to understand the concept of moment. A, B, C, they are the points. At C you have an upward force of 5 Newton, B you have a downward force of 10 Newton, separated by distances 1 meter and then 2 meters. Now if you are asked to find the moments at A, B and C, I have taken numerical values here. Considering clockwise moment as positive, anti-clockwise as negative, moment at A, so moment about this point A will be, I have to take the moment of this force as well as moment of this force from the about the point A. That means distance should be measured from point A. That is very important. So now about the point A, the moment of this force will be 5 into 1 and it is giving anti-clockwise moment. So that is why it is minus 5 into 1. And moment of this 10 Newton force about the point A will be 10 into 3. 1 plus 2. Distance you have to take from A because we are writing the moment about A. 10 into 3. So it will be minus 5 plus 30, which is 25 Newton meter. So because it is force into distance, unit is Newton meter. If force is in Newton, distance in meter, it is Newton meter. If force is in kilonewton and distance in meter, it is kilonewton meter, like that. If the distance is in millimeter, force is in Newton, then it will be Newton millimeter, like that. Huh? So this is the value. So 25 is positive, therefore the net force, the net moment at A is clockwise 25 Newton meter. Similarly, moment at B, MB, here. Now I have to measure the distance from here now. So if you take here, the moment of this 5 Newton force will be clockwise. It will be clockwise 5 into 2. Distance is 2 meters. So it is 5 into 2. And moment of this force, 10 Newton force, will be 0 because the 10 Newton is passing through that point B. So when you are calculating moment of at B, due to this 10 Newton, it will be 0 because perpendicular distance is 0. So it will be 5 into 2, 10 Newton meter, it is clockwise. So clockwise is positive. Then moment at C, this value at this point. So due to this force, it is 10 into 2, 20, positive, clockwise, it is clockwise. Due to this 5 Newton force above the point C, moment is 0 because it is passing through the point C. So therefore, it has got 10 into 2, 20 Newton meter. Once again, it is clockwise. So this is how we can find out the moment of a force at different points. So whenever you are finding moment of a force, you should be very careful when measuring, in taking the distance. Distance should be measured from the point where you are writing the moment to the line of action of the force. That is how we have to write down the distance. Now one more problem, one more example I will take, wherein you have an inclined rod. Let us say this is an inclined rod. On this rod, so AB is the inclined rod. The length of the rod is 5 meters. Let us take the length as 5 meters. It is making an angle of 20 degrees with the horizontal. Now I will take a force here at an angle. So for this force I will take 100 Newton. 100 Newton at an angle of 30 degrees with the axis of the rod. So this is the rod. 30 degrees with the axis of the rod. Now let us calculate the moment of this force about the point A. So MA. I need the value of moment of this force about the point A. Now if you see the diagram, since this is making 30 degrees with the axis of the rod and the axis of the rod is making 20 degrees with the x-axis, this total will be now 30 plus 20, 50 degrees. So please observe this. So 50 degrees. Now what happens? Whenever an inclined force is given, the moment is calculated by taking the moments of the component forces. So what we have to do now here is, we have to resolve this force, 100 Newton force, into its components like this. So components will be like this. You can see, start from the tail, move towards the tipper. So horizontal component is this, vertical component is this. So this is the x component, y component. Now you know how to resolve it. The angle made by this force with x direction is 50 degree. Therefore 100 cos 50 is the x component, 100 sin 50 is the y component. So first we have to resolve the force into its x and y components. Now the moment of this force, 100 Newton force, which is given about the point A, is nothing but the moment of this 100 cos 50 force about the point A plus, that means you have to add. You have to take the algebraic sum. Add means algebraic sum. If it is clockwise, it is positive. If it is anti-clockwise, it is negative, like that. So you have to take the moments of these two forces about the point A, and we have to take the algebraic sum. So for finding the moment, we need the distances to the lines of action of the force. Now how to find the distance? Now I write one more diagram. This is AB. AB. Now you have this 100 cos 50 acting like this, 100 sin 50 acting like this. Instead of taking this force, I have taken the component forces. Now this is 5 meters. This is 5 meters and this is 20 degrees. So observe it, it's very important. 20 degrees. These are given. Now I will complete this triangle, right angle triangle. Let me take this as C. This point as C. Now in this right angle triangle, I need this distance and I need this distance. From the trigonometrical ratio, you can compute these two distances. So if I take this as x, this is as y. So cos 20 is equal to adjacent side by hypotenuse, that is x divided by 5. Therefore, x is equal to 5 cos 20. Similarly, sin 20 is y divided by 5. Opposite side divided by hypotenuse. Hypotenuse is 5 meters. So from this you will get y is equal to 5 sin 20. So x is 5 cos 20, y is 5 sin 20. Now you can compute the value using the calculator. So 5 cos 20, 5 into cos 20 is 4.698. So this value is 4.698 meters, whereas this 5 sin 20 is 5 into sin 20, which is 1.71 meter. 1.71 meter. So these are the distances now. X and y distances we have found out. Now I will write the moment at A, that is MA value, will be equal to, when you are writing the moment, use the convention clockwise positive, anti-clockwise moment negative. Now I have to take the moment due to this force as well as this force. Then I have to algebraically add. First I will take this horizontal component 100 cos 50. Please note that this 100 cos 50 force is acting at a distance of y. So for horizontal forces, distances will be vertical. For vertical forces, distances will be horizontal. That means here this 100 cos 50 is giving what type of moment? You see here, arrow is here. You have to move towards A because I am calculating the moment at A. So you have to come like this. The nearest root is this. So that is clockwise. So clockwise is positive here. Plus 100 cos 50 is the force multiplied by which distance I have to take? I have to take distance y here. Distance y. Because it's horizontal force from point A, distance to line of action always we can extend it. So this distance is y here. So I have to take multiplied by y. Then come to this 100 sin 50 force, vertical component force. This 100 sin 50 arrow is like this. So to come to A, the shortcut route is like this. You have to come in the anti-clockwise direction, which is negative. So minus 100 sin 50 is the force multiplied by x. X is the distance now. So this line of action, this force, if you extend the line of action from the point A, you have to take the perpendicular distance, which is x here. Now substitute for x and y and simplify, you will get the MA value. So it is 100 cos 50 multiplied by y value is 1.71 minus 100 sin 50 multiplied by x value 4.698. So if you simplify this, you will get 100 into cos 50 into 1.71, which is 109.92. 109.92 minus 100 into sin 50 degree into 4.698, which is 359.89. 359.89. So that means the answer is, so 109.92 minus 359.89, which is minus 249.97. 249.97 Newton meter. Be careful about the unit. So it is force is in Newton and distance is in meters. Therefore, unit of moment is Newton meter. Please note that you are getting negative sign here. That means the net effect is anti-clockwise. The meaning of that is this force tries to rotate this rod in the anti-clockwise direction with a moment of 249.97 Newton meter. So this positive negative sign indicates whether it is clockwise or anti-clockwise with respect to that point A. So this is the case of an inclined force acting on an inclined bar. So inclined force with inclined bar. 20 degree is the incline of the bar. 30 degrees is the inclination of the force. So finally it will be 30 plus 20 with respect to horizontal. Please note that whenever you are doing such problems, you take global x-axis, global y-axis like this. With respect to global x and y-axis, you resolve the forces and you calculate the moments of those components of the forces about the point about the point under consideration.